In the video dedicated to higher order Bessey sequences, I make the following statement. A complementary pair of Bessey sequences exists for each packet of size 2 to the n where n is odd. Now, the point I wish to make today is that in the case of an even exponent, all is not lost. We still get a sequence that has remarkable symmetries. It just will not have the same degree of symmetry as a bona fide Bessey sequence. Okay? So I'm showing you here the construction that was shown in that previous video devoted to higher order Bessey sequences. And so what will happen is for each even subscript here, I've labeled the sequence as a Quasi-Bessey sequence. And in the case of an odd subscript, we get a true Bessey sequence with all of the wonderful symmetries that I showed you in that previous video. Okay? Now the one I wanted to demonstrate today is a Quasi-Bessey sequence of length 16. And I hope to impress upon you the remarkable nature of this sequence, even though it does not quite achieve the degree of shuffle and variance that a true Bessey sequence enjoys. Okay, so let's take a look at that. And here is just a summary of what I just mentioned. So for even exponents of 2, we get a sequence that has an OSO CMA structure. These will be called Quasi-Bessey sequences. And here are the Bessey sequences featured in the earlier video where the power of 2 is odd. And we have shown you Bessey sequences of length 8 and length 32. So today we'll show you a Quasi-Bessey sequence of length 16. Okay? Now to do that, I thought I would just begin with a little demonstration here. So I have a packet of 16 cards here, and I'll lay them out for you to look at. Okay, so what we're going to do today is we're going to test the validity of something called the law of attraction. Now the law of attraction is a claim that positive thoughts attract positive outcomes. Negative thoughts attract negative outcomes. And so we're going to put that to the test today. So let me just explain to you the test that we'll use and the procedure we'll go through to scientifically test the validity of that law. Okay? So the two steps that we'll perform in the case of the positive and negative thinking test will be the following. We will simply perform what's called a Klondike shuffle. This is where you take the top and bottom cards off as 1. And then we'll perform something called an LR shuffle. L is for left, R is for right. So this is just a left-right shuffle. Now to have you participate in this test, I'll have you tell me how you would like these stacked. Do you want the left on top of the right or the right on top of the left? You want right on left? Okay, very good. Now, the goal of this little exercise together today is we're going to have you concentrate on something negative first. We'll see how you do when negative thoughts pervade your mind. And the way that we'll detect whether those thoughts are influencing kind of the world around you is we will count up the number of matching color pairs as we create pairs of cards on the table. Okay? So we'll take it as evidence that if you are able to match up a lot of these pairs, then perhaps your positive thinking is actually influencing the process. And if you fail miserably in matching up color pairs, then perhaps your negative thoughts had played some part in that. Okay? So those are the parameters of our test today. Okay, so what I need you to do is focus on something negative, something that is quite disappointing, or something that just makes you feel down. And I'll give you a minute to do that, and I'll do the same. I thought we would combine our mental energies together and see if we can actually verify whether or not this law is actually valid. Okay, so think about something negative for just a moment. Okay, I have a negative thought in mind, kind of a depressing one actually. Okay, so let's see if our negative energy together is going to affect the outcome of the test here. So if you remember, the procedural steps for the test will always be the same. We will Klondike pairs of cards to the table. Okay, there we go. And then we'll perform this left-right dealing of the cards. Okay. Okay, hold on to that negative thought. Really focus on it. I have mine in mind, and I'm not going to let it go until this test is completed. Okay, so with our negative energy, let's see how many of these color pairs we're able to match. Okay, so that would be a fail. Okay, no match there in color. No match. Oh boy, no match. Remember, there's eight pairs here. No match again. No, now don't laugh, because that's a positive thing. So hang on to your negative thought, and I'll do my best to do the same. Another fail. Oh boy. Are we going to get any of these? Nope. That is a 100% failure. Okay. So I don't know if that's sufficient proof there that perhaps our thoughts influence the process. But let's go ahead and let's just try that again. I really kind of hope that we can at least get some of these to match up. I personally would like to disprove this law. I'm not sure if I actually believe it here. So focus on that negative thought again, and let's see if we can get any of these to match. Oh, come on. Oh, I'm getting negative just by being frustrated here. I guess that's guaranteeing that we'll never match these ridiculous cards. Oh, you've got to be kidding me. Okay, I think the problem is we're just not mixing the cards well enough. Because surely if we mix the cards well enough, the universe is going to give us a break here. How should I stack? Left to right? Okay. Okay, very good. Should we even do let's do 8. Oh man, let's just really mix these cards. Okay, and so let's just, why don't you decide, we'll kind of stack these on top of those, or the bottom on top of the top ones. You want top on bottom? Okay, we'll do that. Okay, and then how would you like these stacked? We could even do something called a leapfrog. You kind of hop over. You like that idea? Okay, we'll hop over here. Left on right or right on left. Okay, surely now we will get some matching pair. Now hang on to your negative energy there. Okay, don't get all happy about thinking about leapfrogs or something. Hang on to that negative thought. Okay, we're going to get at least one to... Oh boy. It's funny how negative emotions feed on themselves and positive emotions feed on themselves. And so I can just feel my frustration growing as we fail this test, which is probably just guaranteeing that we will not ever succeed. You've got to be kidding me. None of these are matching. Okay, well, I don't know. I think that's some pretty good evidence there that something's going on, at least in the case of negative energy. So we perhaps have kind of verified that negative energy can have a negative impact. Now, what about positive thinking? Because that's what most people want. They don't want they don't want bad things to happen in their lives. So what about if we have positive thoughts and we kind of look at the world through rose-tinted glasses and just see the world the way that we would like it? So what I need you to do now, and I'll do it too, is concentrate on something or a number of things that you would view as very, very positive. Things that would just make your day or make your life even. And things that would just really, really brighten your outlook for the future. And I'll do the same. I'll try to think of something or a few things. Okay, so have you collected some really strong, compelling, positive thoughts? Kind of hopes for the future? Okay, I think I have too. So let's go ahead and perform our actions for this test. The actions are always the same. So we perform a Klondike shuffle. And throughout all of this, it's important. Hang on to that positive thought. And I'm doing the same here. Okay, and then what was the other action to make this test efficacious? The left-right. We have to do a left-right dealing of the cards. Okay. Yeah, I remember now. Okay, so let's see if our positive thoughts and kind of positive attitude about life and the universe around us, let's see if it's influenced or in any way affected our success rate here. So the hope is that we can get, I guess, at least half of these to match in color. So let's see how we did. How did we do? Oh, we got one. Finally. Well, I guess that's evidence that maybe there is something to positive thinking. Yes, we got 2. 2 out of 8. Oh boy. 3. 4. 5. Man, I'd love to know what your positive thought was. It must have been pretty darn potent. Oh, yes. 6. 7. I would think by elimination, we nailed it. We went from a 0% matching rate to a 100% matching rate. Now, if you think about the steps of the tests, the only thing that was different, the only element or factor that changed was our thinking. Our negative thoughts resulted in no matches whatsoever, and our positive thinking and positive thoughts resulted in a perfect color matching of these cards. Boy, oh boy, I think there really might be something to this principle called the law of attraction. Okay, so that is a little demonstration. Now we could actually perform this over and over again. It resets. So you perform that again. And what I'll be showing you in just a minute is there's far more you can do than what I've done here. I've done the bare bones for card shuffling and that kind of thing. I just wanted to show you kind of the essence of what's going on. Okay, so what is going on here? Okay, well, if we go back to our little piece of paper from last time in the higher order video we did for Bessey sequences. So what we're focusing on here are sequences that are even powers of 2. Now, they will always have an OSO CMA structure. So let me just quickly remind you of what that means. Okay. Now C here stands for 2-cycle. M stands for mirrored. And A stands for AMP. And that's short for adjacent mirrored pairs. Okay. So what the OSO is referring to, in fact, let me just show you here. Let's see, we could probably just go like this. Now, these are O's, like the letter O, O for opposite. This little S here corresponds to the M, and then the O here corresponds to the C for 2-cycle. Okay? So what this means then is the sequence that we started with is a two-cycle relative to opposite color or opposite value. It's mirrored relative to the same color or same value. And it's an AMP, or its adjacent mirrored pairs are opposite relative to color as well. Okay, so let me just show you the sequence itself that I started with. Okay, so the packet structure I started with is the one right here. Now this isn't actually the exact ordering of the cards. I just reconstructed the sequence itself as far as color distribution. I just kind of recreated it here. Okay, so what we started with is an OSO CMA sequence, and this is what we're referring to as a Quasi-Bessey sequence. So it's a sequence that naturally occurs in the construction of these higher order Bessey sequences. It just ends up being, those intermediate ones, okay? So that's what we're kind of focused on here. So if you want to think of the ones as red and the zeros as black, you can see that we have, red, black, black, red. Now it shifts, black, red, red, black, and then black, red, red, black, and then red, black, black, red. Now you may recall from that earlier video, now this right here is a Bessey sequence of length 8. It's the one that the entire series is devoted to when talking about Bessey sequences. Now to get the other half for this sequence of length 16, what we do is we create the inversion of that and then concatenate it with this one. Well, the inversion is where zeros and ones switch places. So now, switching places, we would get a 0, 1, 1, 0, 1, 0, 0, 1. And that's exactly the sequence that is being placed to the right of our original Bessey sequence. Okay? So those two concatenated together is what we call a Quasi-Bessey sequence of length 16. Okay? Now I have up here, I have a diagram that kind of shows you the effect of these various shuffles on this packet structure. And here I list all of the packet structures that result from the various mixing that I've shown you within this video today. Okay, so as intermediate packet structures, we will actually have an OOS and an SOO. Okay, in fact, why don't we just verify that middle one just for kind of practice here. So why is this one an OOS? Okay, so remember that first little letter here refers to a two-cycle structure. Well, the claim is it's a two-cycle relative to opposite value. Well, to check that, what you do is you look at the first entry in the first half, the first entry in the second half of the sequence. And you look at them and say, okay, are those the same value or are they different? So here they're different. So we would say that they're of opposite value. Now, so we move one to the right, we get a 1 on the left and a 0 on the right, so those are of opposite value. So as you move from left to right, you'll see that the digits flip. They'll be of opposite value to each other as you look at it as a two-cycle. Now the middle letter, of course, refers to its mirrored structure. So here, what we're doing is we're looking at the outer values. So the 1 and the 0, well, those are of opposite value. If you come in 1, those are of opposite value. If you continue to do that, you'll eventually arrive at the very two middle values, which are opposite. Okay? Now the last letter refers to the AMP structure. Now, AMP stands for adjacent mirrored pairs. So what we do here is we just look at the digits, look at the values in pairs moving from left to right. We ask the question, are they different or are they the same? Well, in this particular sequence, they are all the same in pairs, within the pairs. Okay, so we say that this is an OOS CMA sequence, or that it has an OOS CMA structure. That's another way of saying the same thing. Okay, so as you can verify, if you begin with this structure right here, performing a Klondike shuffle actually converts it to this one here. So you'll end up having this after a Klondike shuffle. After the LR shuffle, once you've done the Klondike, it will take you to the bottom structure here, an SOO, and then a Klondike of this sequence takes you back to our original configuration. Now, I should say it's the original configuration organization. The cards will have been permuted. The blacks and reds will have changed places among themselves as red cards separately or as black cards separately, okay? But the overall pattern of cards will remain the same. Now, I do have to include, of course, the caveat that, remember, Bessey sequences and Quasi-Bessey sequences come in pairs, okay? So here is the Quasi-Bessey sequence of length 16 that we're using here. Well, its inversion is also called a Quasi-Bessey sequence of length 16, okay? So these will always come in pairs, okay? So it could be that within the mixing process that we're talking about over here, by the time you perform the Klondike and then an LR shuffle and then a Klondike, it could be that it changes this from a sequence that begins with a red and then black, black, red, and so forth, to one that starts with a black, red, red, black. And then the other cards would be in agreement with the organization of an OSO structure. Okay? So you either get the original kind of configuration of the cards relative to color, or you get its inversion. And both of them are equally valuable, equally helpful. Now, I have a very important note, and this is just a wonderful property of this sequence, is that the OSO structure is invariant, unhurt by an LR shuffle or this dealing out into piles where the number of piles is a divisor of the packet size. Or this is called a judicious kind of dealing out into piles where I do like a leapfrog stacking, okay? So in fact, why don't we just demonstrate that here? So just, focus on the fact that we're looking at an OSO right now. So what does that mean? Well, that means we're going to have a red, black, black, red. So you can just kind of focus it here. Focus on this one here. And then, so once we've gone through those 8 cards there, it will repeat, but in reverse order. Now it's black, red, red, black, and then red, black, black, red. Okay, so we're just kind of reading off that sequence. Well, if we go through and perform an LR shuffle with random stacking, now that's really important. Virtually everything that I've shown in the Hidden Structures, on the Hidden Structures channel, involves shuffling or dealing where if there's a choice between doing something from left to right or right to left, it won't actually matter which one you choose. It won't prevent you from accomplishing what you want to accomplish. So that's important to note. Okay, so what happened here? Did it kind of flip it to its inversion? It did indeed. Okay, so instead of, we were kind of assigning 1 as for the reds and 0s for the blacks. Well, look, we're starting with a black now. So it's like 0s and 1s switch places. So we actually get the, quote, inversion, okay? And if you note here, here's the inversion for the original Quasi-Bessey sequence of length 16. It's right there. So here we would be looking at black, red, red, black. Perfect. Red, black, black, red. That's true. Red, black, black, red. Yep. And then way down here, black, red, red, black. And that is the case. Okay, so that LR shuffle changed the sequence into its inversion, okay? But as far as the structure type, it left it alone. It's still an OSO CMA sequence, okay? And that will be true if we deal out into 4 piles or 8, and even with judicious stacking, like leapfrog stacking. Okay, so I thought I would just quickly step through this effect so that you have this kind of in your notes here. So where we are, well, let me just step through it on the piece of paper here so that you have it. Okay, so the goal is to match up as many color pairs as possible. We're testing the law of attraction here. So you start with this kind of structure, which is what I had just a moment ago. Okay, so I'll lay out one version of an OSO CMA structure. So there you go. Okay, and then you just explain to the spectator that this testing of the law of attraction is a fairly simple test. It involves just 2 steps. And we'll perform the same steps for when we're testing positive thinking versus negative thinking, okay? And the 2 steps are you just Klondike shuffle the cards, and then you do an LR shuffle with random stacking, okay? Well, from our little chart here, what is that going to do for us? It's going to take us here. So once we do the Klondike, we'll be looking at an OOS CMA structure, okay? And then if we perform an LR, it takes us down to an SOO CMA structure with random stacking here. It won't change that outcome of the structure type. That's important to emphasize there. Structure type. Okay, and we can even just verify that really quickly, because so what this would tell us then, or what should be the case here, as I spread these out, and you can verify it for yourself. So what are we're claiming that we have either this sequence or its inversion. Well, in this case, we actually got exactly this sequence if the ones are reds, right? So we get red, black, black, red. Okay, we have that. Now we get black, red, red, black. Yep, we got those just fine. And now we should get red, black, black, red again, which we have right there. And then we should finish with a black, red, red, black. And we did. Okay, so you've demonstrated the 2 steps. Now the demonstration of the 2 steps, it serves a couple of purposes. One is to just make the spectator aware of the procedural steps that you'll be performing so that they feel more comfortable with them. But in the process of doing that, you've actually converted your original sequence to an SOO structure, okay? Which is where we actually need to begin the negative thinking test, okay? So now we have a SOO structure, as we just verified, and then you have the spectator focus on some, negative thought or situation, just something that really makes them feel gloomy, okay? And then once you've kind of focused on that negative situation or outcome, we go ahead and just Klondike shuffle. We perform our actions here. So we Klondike shuffle while holding on to our negative thought there, okay? And then the next step is to go ahead and just do a left-right deal. Now, we won't stack yet, okay? So we won't stack yet. So I need you to kind of understand something that will kind of be a key to making all of this make sense, actually. The actions that we just performed, we performed the Klondike of this sequence structure. So that puts us here. And then we did a left-right dealing, okay? So just think about this. We're back to our OSO structure right here, okay? So this is where we were before I started the LR dealing, okay? Before I went left, right, we were looking at this right here. Well, you can see what's going to happen. right? So that first one, like red, goes into the left pile. Next one, black, will go into the right. And then the next left card dealt will be black. And the next right-hand card to be dealt into that pile will be red. And so you can see that as pairs, we're going to get these at every level being of the opposite color, okay? Now that's a consequence of the fact that this is an AMP relative to opposite value. Okay, so in pairs, these will be of opposite color in our case, since we're looking at the color of the cards here. Okay, so that will guarantee that no matter how many times we deal this into a left and right pile, and then randomly stack them, the cards at every level will be of opposite color. Okay, so that's a consequence of a couple of things. It's a consequence of the fact that the OSO is an AMP relative to opposite value or opposite color. It's also a consequence of the fact that the LR dealing preserves this structure type. Okay, so when we go to stack these again, it's going to still be an OSO structure type. It's not going to leave that kind of category of organization of the cards. But right now, they're going to actually be of opposite color at each and every level. Okay, so you can go through and kind of, claim that your negative thought or negative energy is just causing you to fail this test. You can't get any of these silly cards to match in color, okay? And then you can actually perform as many of these left-right deals or deal into any number of piles that's a divisor of the packet size. So if you remember, I dealt into 4 piles, and then you can stack from left to right or right to left, or you can do a leapfrog if you like. Okay, and the spectator is certainly invited to dictate how these are stacked. Maybe they want to go right to left doing a leapfrog, that's just fine. Okay, this is random as well for the stacking. Okay, so you can do as many of those as you like. Now there's additional shuffles you could do that I'm going to mention at the end. But it is true that we don't quite have the same enormous list of shuffles that preserve this structure type. There's quite a few, but it's significantly shorter as a list of invariant shuffles for this structure type. And it's just a reflection of the fact that this is a Quasi-Bessey sequence. It doesn't enjoy all of the same symmetries that a true Bessey sequence does. But boy, does it still have some remarkable properties, as I've shown you in this demonstration here. So you can perform the negative thinking test for quite a while, actually. You can just keep performing that. And I even say here, in an effort to ostensibly confirm the negative influence of your negative thoughts, you can perform the LR shuffle, which I did, or this dealing into piles with kind of, stacking from left to right, right to left, or leapfrog decided by the spectator. And you do that while the two of you are focusing on your negative thoughts. And then you try again to get some of them to match, and none of them will. None of them will. Okay? And then from there, we just moved on to the positive thinking test. And so here, you just take a little break and say, okay, well, boy, our negative thoughts really kind of apparently made us fail miserably with our tests there. So let's see if negative energy is equally potent here. Okay, now you have to realize that at this point, because of the negative thinking test, we will have finished with an OSO structure. Okay, so what that means is, okay, let's just kind of tie this in here. Remember, this is an OSO structure, and now we're going to perform a Klondike. We're having the spectator think about something positive, and once you've done that, you say, okay, let's perform the same actions as before, which is true. We'll perform a Klondike, okay? And that's what we did for the negative thinking test as well, okay? But look on our chart there, our little diagram, if you start with an OSO structure, which we just did, and we Klondike shuffle it, we'll now have an OOS. Well, what does that mean? Well, focus on the last letter there. S is for same. And that last letter, because of where it is referring to the AMP structure of the sequence. Well, once again, what that means is if we come over here to this structure type, if you take the digits or the cards in pairs, they'll be of the same value or the same color. Okay? But why is that helpful? Well, we're going to follow the Klondike shuffle with an LR shuffle. So just imagine if the two cards are red and you do a left-right, then guess what? At that first level, they're the same color. Then the next two are black. You deal those out, they're the same color. They're both black. Okay, and in fact, I can even just show you the actual cards themselves so you don't have to think about it all in the abstract. These cards are really kind of sticking together for some reason. Okay, so let me just kind of verify that we have the structure type that we're talking about here. So we have, like two reds, two blacks, two blacks, two reds, and then two blacks, two reds, and then two blacks. Okay, so what that will mean is when you deal these out left, right, at each level, these cards are guaranteed to be of the same color. Absolutely guaranteed. Okay, and so you tell the spectator, I wonder if our positive energy or positive attitude about things is going to increase our chance of success here in matching up color pairs. Let's say, oh, we got one. That's great. And then you just go through and show that you nailed all of them. Well, you had to, because this is an OOS CMA sequence. It has no other choice. You would have to have matching colors at each level when it has this structure type. Okay? So that would be a 100% success with the positive thinking portion of your test of the law of attraction. Okay? And then if you want to repeat this, you just go through and say, okay, well, let's go back to our negative thinking. Think of something really sad or unfortunate. Let that soak in. And then you go ahead and you perform a Klondike. And then you do a left-right deal and reveal that they never match. They never ever match. Then you can randomly stack those and perform any of these. Just keep dealing them into 2 piles, 4 piles, even 8 piles. And then combine those and the way that we've been talking about, left to right, right to left, or leapfrog. And then if you deal them out again, left, right, those cards will never ever match. None of them will match in color. Okay, so you can try to get the negative thinking portion to succeed at least a little bit, right? But it never will. Okay, and it has to do with the structure type here, because an OSO, remember, an OSO focus on the AMP structure. This is where we're looking at the cards in pairs. When those are dealt out, left, right, they'll always be of opposite color or opposite value here for the digits. Okay, so that's just kind of a quick look. I guess I can turn the page here. I'm just pointing out that at every level of the 2 dealt out piles, this is still the positive thinking portion. We were successful. And then I've kind of jumped ahead and said, hey, you can repeat this whole thing as many times as you like. It completely resets itself. Okay, now before we leave this topic of Quasi-Bessey sequences, I want to point out that some of the shuffles that work for bona fide Bessey sequences, if you remember, we had an enormous list. So you may remember from the earlier video dedicated to higher order Bessey sequences, I gave you quite a list. All of these shuffles, plus additional ones, actually preserve Bessey sequences of length 8. Okay? And they also preserve Bessey sequences of length 32. Okay? Now, some of these will no longer preserve a quasi-Bessey sequence. Okay, so that's why they're not listed here. And in many cases, what will happen, as you can see, is we'll need to pair And it's not the end of the world, but we'll need to pair some of these wonderful shuffles that used to work individually by themselves. We have to pair them together. And paired together, they'll preserve this OSO structure just fine. Okay? So we do have the LR shuffle and the dealing out into multiple piles. We've been using that. That works great. But some of these other ones, the Mange and Klondike, if you pair them in either order, the Bessey 1-1 and Mange, if you pair those in either order. The Mange is kind of a one-sided one. Mange with a 50% coating preserves this just fine. Mange with the Bessey 2-2, it's just fine. And then a 50% coating pairs with just about all of the other ones, okay? So, you know, there is still much that can be done. And so during the mixing phase, I could have done a Mange and then followed by a Klondike, that'd be fine. Or a Mange followed by a 50% coating. Or I could have led with a Bessey 1-1, that's fine, as long as I follow it with a Mange. Yeah, that preserves this just fine, okay? And then, of course, the Charlier 1 will always work because it's just a 50% cutting of the cards. And these sequences are all invariant relative to a 50% cut. And then the KLRC is actually a false shuffle. It either reverses the order of the packet or preserves the original order. And then this is the first shall be last and the last shall be first shuffle. And it's actually just a packet reversal. Well, packet reversals don't hurt these sequences. Either, like in the case of the OSO, it leaves it identically as it is. If you read this from left to right or right to left, you get the same sequence. The other ones, you'll get the inversion, right, which is not a problem because these will be in pairs. So as pairs, they serve their purpose just fine. Okay, so that's something I wanted to point out. And then one other thing I was hoping to show you here, if you're wondering, okay, well, you know, it's a bit of work to set up a sequence of length 16. Well, here it is. You know, setting it up in this way, you know, it just seems like it'd be kind of fussy or something. But let me just point out that if you have the packet, and I'll go ahead and just do it here right in front of you. If you have the cards in blocks, like whatever cards and that's the key. The 1 can represent anything whatsoever. So it's really, we're just saying, okay, we want whatever these cards are, we want them to be grouped together at the end. And whatever these are, the zeros, we want them grouped together. But you're free to have anything assigned to these labels. I mean, that's the power of the whole thing. And you saw that with Bessey's sequences of length 8. Thanks to Warner Miller, he's come up with a lot of really fun ways to use the invariance of the Bessey sequence of length 8. Okay, so what I'm explaining here is that if you started with something like this, it's not too hard to convert it to that, okay? So what will happen, let me just show you the pattern here, is if you want to associate, you know, the 1 with a T and the 0 with a B, because what we're going to do is we're going to draw from the top or bottom according to the instructions here. So if you want to think of the 1 as saying, take 1 card from the top. And the 0 says, take 1 card from the bottom. Take another card from the bottom. Take 1 from the top, and so forth. So if you can just remember this, it's going to be top, bottom, bottom, top. Bottom, top, top, bottom. Okay, now that is the standard Bessey sequence of length 8. Well, to get the other half, as I mentioned earlier, you just put the inversion over here. So it really is just the mirror image. Do you see that? If you kind of cut right down through here, you're looking at the mirror image of the first half becomes the second half. Okay, so what does that mean in practice? Well, I have, you know, half red, half black in blocks, right? So I kind of, you know, silently to myself, I'll think, okay, top, so I'm just reading this, top, bottom, bottom, top, bottom, top, top, bottom, and now I kind of like reverse that. I go with the inversion. I do the little foursome that I just did there, one more time, bottom, top, top, bottom, and then top, bottom, bottom, top. Okay, and so what that does is it very quickly converts this 2 blocks of 8 cards into a Quasi-Bessey sequence of length 16. Okay, and you can kind of just verify that that works just fine. Okay, so we get so black, sorry, red, black, black, red. There you go, and then black, red, red, black. Perfect. Then once again, black, red, red, black, right there, and then red, black, black, red. Okay, and then you're off to the races. You have this Quasi-Bessey sequence of length 16, and it has some wonderful invariance that you can take advantage of. And the law of attraction routine is just one of countless applications you could come up with to take advantage of the fact that this sequence survives a tremendous amount of, quote, randomization. And that's what the spectator thinks. They think the cards are being randomized, especially because they're making key decisions like, should we stack left on right or right on left? Well, the reality is that makes a difference to the ordering of the cards. And they will know that intuitively. That makes a difference. But it won't make a difference to the structure of the cards. That's the difference. The ordering of the cards will be permuted or altered, but the overall structure will be preserved. Okay, it's invariant under these many shuffling procedures here. Okay, so anyway, I just wanted to let you know that there are some wonderful things that you can do with these Quasi-Bessey sequences. And so really every power of 2 then, every single power of 2, there will either be a Quasi-Bessey sequence that goes with it or a bona fide Bessey sequence with all of the invariants of the Bessey sequence of length 8 that I've demonstrated in this quite lengthy series devoted to Bessey sequences. Okay, so I just wanted to, make sure I didn't leave you with the impression that these even powers of 2 just give you sequences that are useless, and they don't really seem to have much in the way of symmetry or much to offer in the world of mathematical card magic. But they do. They have a lot to offer. Okay. But the primary difference will be that sometimes it will move it from one structure type to another. So if you kind of know where you're going and what's happening with that structure, you can have complete control over the ending overall organization of the cards at the end. Okay, and this one's especially nice because we have shuffles that leave that alone. So you don't really have to worry about, okay, I'm going to move it over to this type and then take it over to this and so forth. So these many shuffles that I've shown you, so these here are nice. And then these are just some other groupings that I've discovered that if you pair these up together, you essentially accomplish a lot of the shuffle invariants that we had for a Bessey sequence of length 8. So I hope that kind of explains more of what I was talking about in that one video dedicated to higher order Bessey sequences, and maybe filled in some gaps for people, that not only do we have odd powers of 2 giving us just wonderful structures, a true Bessey sequence, but even powers of 2 give us structures that these Quasi-Bessey sequences that still can be used to accomplish this seemingly impossible, quite honestly. So, okay, well, thank you for watching. I just wanted to kind of round off, or at least give a fuller picture, or a fuller glimpse, really, because it's really just a glimpse, a fuller glimpse of this world of higher order Bessey sequences. So thank you for watching.